When you look at the seas and oceans on a map, you might think that they just flow into each other. Like there's really only one big ocean and people just arbitrarily gave different names to its different parts. Well, guess what? You'll be amazed at how much more substantial the borders between them actually are. For example, the border between the Pacific and Atlantic Oceans is like a literal line between two different worlds. It looks like the two oceans meet at an invisible wall, which does not let them flow into each other and mix their waters. Why on earth does that happen? Obviously, there's no actual invisible wall inside, and water is just water. So what could be interfering with its mixing? Well, the thing is that water isn't just water. There can be different kinds. The Atlantic and the Pacific Oceans have different densities and chemical makeups, the level of salinity, and other qualities. One can see by their color that they are far from the same. Borders like this, between two bodies of water with different physical and biological characteristics, are known as haloclines. Jacques-Yves Cousteau discovered one of them while he was deep diving in the Strait of Gibraltar. The layers of water with different salinity looked like they were divided with a transparent film, and each layer had its own distinct flora and fauna. Haloclines appear when water in one ocean or sea is at least 5 times saltier than in the other. You can create a halocline at home if you pour some seawater or colored salty water in a glass and then add some fresh water on top of it. The only difference is that your halocline will be horizontal and ocean haloclines are vertical. For those of you who were paying attention in chemistry class, you might remember that if you have two liquids with different densities in one space, the denser liquid should eventually end up below the less dense one. By that logic, the border between the two oceans should look not like a vertical line but a horizontal one, and the difference between their salinity would become less obvious the closer they got to each other. So why doesn't it work like that? Firstly, the difference in density of the two oceans is not big enough for one of them to sink down and the other one to rise up, but it is big enough to not let them mix. Another reason is inertia. There's an inertial force known as the Coriolis force, which influences objects when they are moving in a system of axes, which in turn are moving as well. In simpler terms, the Earth is moving, and all the moving objects on it are carried along, acted upon by this Coriolis force, deviating slightly from their natural course. As a result, the objects on the Earth's surface don't move straight on, but deviate in a curve, clockwise in the northern hemisphere and counterclockwise in the southern. But because the Earth is moving slowly, after all, it does take the planet a whole day to make a full circle around its axis, the Coriolis effect isn't easy to observe in the short term. It becomes easier to notice only in long-term intervals, like with cyclones or ocean flows. And this is why the direction of flows in the Atlantic and the Pacific Oceans is different. This difference also doesn't let them mix. Another important difference between these two ocean waters is the strength of molecule connection, or surface tensile strength. Thanks to this strength, molecules of the same kind hold on to each other. The two oceans have totally different surface tensile strengths, which also doesn't let them mix. Maybe if the waters were completely still, they could gradually start mixing over time, but as they flow in opposite directions, they just don't have time to do this. We think that it's just water in both oceans, but its separate molecules meet for just a very short moment and then get carried away with the ocean flow. But if you think that it's only the Atlantic and Pacific Oceans that don't get along with each other, you are sorely mistaken. There's lots of places on the planet where the waters of the two seas or rivers don't mix, and for even more weird reasons. For example, there's a different kind of border called a thermocline. These are borders between waters of different temperatures, like between the warm water of the Gulf Stream and the much colder North Atlantic Ocean. But the most interesting kinds are called chemoclines. These are borders between waters having different microclimate and chemical makeup. The Sargasso Sea is the biggest and most widely known chemocline. It is a sea within the Atlantic Ocean, which has no shores, but is very obviously distinct. You can't not notice it. Let's now take a look at some other spectacular clines we have on planet Earth. And just as a heads up, I might mispronounce some of these names coming up, so please forgive me. First up, we have the North and Baltic Seas. These two seas meet near the Danish city of Skagen, The water in them doesn't mix because of different densities. Sometimes you can see the waves of the two seas clash into each other, making foam. Their waters do mix very, very gradually. That's why the Baltic Sea is slightly saline. If there had been no water coming to it from the North Sea, it would have just been a freshwater lake. Next up, the Mediterranean Sea and the Atlantic Ocean. They meet at the Strait of Gibraltar and have both a different density and salinity. So there's two reasons their waters don't mix. Then we have the Caribbean Sea and Atlantic Ocean. The place where they meet is near the Antilles, and it's very easy to spot. It looks like someone has painted water with two different shades of blue. Another place where these two meet is Eleuthera Island of the Bahamas. The Caribbean Sea water is turquoise, and the Atlantic Ocean water is dark blue. There is also the Suriname River and the Atlantic Ocean, which meet near Paramaribo in South America. How about the Uruguay River and its afflux? These two meet in Misiones province in Argentina. One of them is claimed to be used in agriculture, and the other has an almost red tint to it because of loam during rainy seasons. Here's an interesting one. The Rio Negro and the Solimões rivers, part of the Amazon River. 6 miles from Manaus in Brazil, the Rio Negro and Solimões rivers flow into each other, but don't mix for about 2.5 miles. The Rio Negro is dark and the Solimões is light. They have different temperatures and speeds of flow. Then there's the Moselle and Rhine rivers, which meet in Koblenz, Germany. The water in the Rhine is lighter than that of the Moselle. Okay, how about 3 different bodies, like the Ilz, Danube, and Inn rivers? The junction of these 3 rivers is in Passau, Germany. The Ilz is a small mountain river to the left, the Danube is in the middle, and the Inn is a light river to the right. The Inn is wider than the Danube here, but is still its afflux. Take a look at the Alaknanda and Bhagirathi rivers, which meet in India. Alaknanda is dark and Bhagirathi is light. I really hope I got those right. The Irtysh and Ulba rivers flow into each other in Kazakhstan, near the city whose name is Ust-Kamenogorsk. The Irtysh has clean water, and the Ulba's water is cloudy. Moving further east, the Jialing and Yangtze rivers meet in Chongqing, China. I really hope that's close at least. The Jialing is clean and the Yangtze is brown. The Irtysh River actually has another intersection with the Om River. These two rivers flow into each other in Omsk, Russia. Here, the Irtysh is cloudy and the Om is pure and transparent. Speaking of Russia, the Chuya and Katun rivers meet in the Altai Republic. The water of the Chuya has an unusual cloudy white color here and looks dense and thick. The Katun, by contrast, is clean and turquoise. Flowing into each other, they form a single 2-colored stream that does not mix for some time. On the other side of the globe, we have the Green and Colorado rivers. The place of their junction is National Park Canyonlands in Utah, USA. The Colorado River is brown and the Green is, well, green. The corridors of these rivers go through rocks with different chemical makeup. That's why they have such a big contrast of colors. Last but not least, we have the Rhone and Arve rivers. They flow into each other in Geneva, Switzerland. The Rhone is a pure river that flows out from the lakes of Geneva, while the Arve is cloudy and gets its water from the glaciers of the Chamonix Valley. This is by no means an exhaustive list of all the strange climes on our beautiful planet, but as you can see, it happens a lot more often than you think. These are the kinds of environmental oddities that can really teach you about the way the natural world works. If you're curious enough, of course. Thanks for watching. Oh, and let me know how well I did with the pronunciations. Constructive feedback is always helpful.
Okay, let's try something together. Open any world map you have available. It can be the one you find in your bookcase or even an online version. Take a look at the vast area covered by water. That's 71% of the Earth's surface. And all of that is salt water from the world's oceans. There aren't any borders between the 4 oceans we've all come to know. But oceanographers and the world's countries did traditionally split these waters into 4 distinct regions: the Pacific, Atlantic, Indian, and Arctic Oceans. And here comes the big surprise. The scientific community has recently recognized the 5th body of water. It's called the Southern Ocean, and 3 of the 4 original oceans border it. It circumnavigates Antarctica and the lower portion of the globe and reaches Australia and the southern portions of Africa and South America. What makes this ocean so special? How did the scientific community eventually recognize it? And more importantly, what mysterious creatures does it hide? Let's find out. The Antarctic Ocean, or the Southern Ocean, was first mentioned back in 1937 in the second edition of the International Hydrographic Organization's Limits of Oceans and Seas. That's a mouthful. Back then, this organization considered that it was wrong to consider the Antarctic Ocean as its own distinct body of water. Why? Well, because at that time, an ocean was defined as water surrounded by land and not water surrounding land. However, they reconsidered it in 2000 and voted to include this ocean in the official list. They also decided on the name Southern Ocean over the commonly used Antarctic Ocean. Finally, the organization concluded that the ocean should be considered as ending at the 60th parallel south latitude. But how old is this ocean? Well, many specialists believe it to have formed only 30 million years ago, which would make it the youngest of the world's oceans. It was created when Antarctica and South America moved away from each other during the early stages of our planet's development. This unique water current is a distinctive component of the Southern Ocean, as it helps keep the waters flowing around the icy continent. It's called the Antarctic Circumpolar Current, and it moves to the east with incredible speed. It's estimated that it moves an enormous amount of water per second. Some of the disputes regarding the Southern Ocean also have to do with this amazing current. Some specialists believe it separates the water of the Southern Ocean from the waters of the nearing Atlantic or Pacific. Only the rapid circulating water is considered the Southern Ocean. On the other hand, though, a handful of scientists say that the current actually makes the naming issue more complex by not limiting the waters to a specific geographic location. They believe that the waters in the current are different in terms of composition from waters in the northern oceans because they are way colder and have a lot more salt. Sailors don't really like this new body of water, mostly because of the frequent cyclone-like storms that it experiences. They happen because of the big temperature difference between the ice packs and the ocean waves. As a result, these storms are very difficult to surpass for any sailors that happen to encounter them. I mean, really, these are the strongest winds found anywhere on our planet. More so, the vessels going through this area must also be wary of the frequent icebergs that may pop up every now and then, and also of the low surface temperatures. Just to paint you a better picture, some of the icebergs found here can span over several hundred meters and can exist all year round, regardless of the season. The latitudes from 50 to 70 have even earned the nicknames of Furious 50s or the Shrieking 60s because of these intense year-round storms. Even the landscape is unique. They say the Southern Ocean has bluer glaciers, colder air, and more intimidating mountains than anywhere else in the world. Now, let's get to the mysterious creatures that call this place home, as thousands of species of wildlife live only here and nowhere else in the world. Let's start with the quirky sea pig, or one of the sea cucumbers as it's sometimes called. There are a lot of them in the waters off Antarctica. Why is it called that way, though? Because of its pink hue and round, bloated looks. On a closer look, it even appears to have a little tail and set of ears, just like a pig. They do help a lot with the quality of the waters here, filtering sand and sediment. Then there are the Hoff crabs that live on the floor of the Antarctic Sea. The Southern Ocean is a cold water environment, but crabs are more adapted to warmer waters. So, Hoff crabs gather around the warmth made by volcanic vents. They get the needed warmth and food here. You can find them in large piles, one on top of another, literally filling the space at the vent openings. Now, wonder how they got their unofficial name? Well, it's because of their apparent similarity to the actor David Hasselhoff, whose impressive chest reminded explorers of the crab. Okay. Ever seen a fish that's completely transparent? You'd have to get to these waters down in the south, but they do exist, and they are simply called the ice fish. You can basically see inside them, being completely clear and all. That's because of their see-through skin and because they don't have any red blood cells. Their special power is that they can use antifreeze to prevent their bodies from going solid in the cold waters of the Southern Ocean. Instead of the standard thicker blood, the red one with hemoglobin, ice fish have thinner blood that moves around more easily throughout their bodies, hence giving them the much-needed nutrients and oxygen. Now, is there a monster hidden in these waters? Some people believe this to be the case, and thanks to recent research, we even have video footage of it. Some Australian researchers stumbled upon a bunch of weird-looking creatures that were swimming near the seafloor of the Southern Ocean. This pink blob-like fish seemed to be propelled by a little pair of fins. To quote them on it, it seemed to resemble a chicken just before you put it in the oven. I'm not sure I even want to know what that looks like. It took them some time and research to identify the monster. It's a shy species of sea cucumber, known more by its creative nickname, the headless chicken monster. We've known this creature has existed since the late 1800s, but we've barely ever seen it. And we've only ever captured it on tape once before when it was spotted in the Gulf of Mexico, which is quite far from the waters off the coast of East Antarctica. There's so much we don't know about this creature, like how many of them exist in our waters and how they live, eat, and reproduce. Ever heard of the emperor penguin? It's not a penguin species that just happens to have a crown on its head, if that's what you're thinking. But they are one of those penguins that inhabit this specific location and are also the largest species of their kind altogether. What makes them special is that they make their colonies on the sea ice, and most of them never step foot on land. More so, penguin dads lose almost half their weight while incubating the eggs. They're also fascinating swimmers, able to dive deeper and longer than any other bird, up to 700 feet. Not to mention they can stay submerged for up to 18 minutes at a time as they gather food. We have yet to uncover all the secrets of the mysterious Southern Ocean, but it's clear that it's home to some unique and fragile marine ecosystems. Recognizing it as a new ocean could be one way to focus the public attention on it and help its conservation. Ooh, you're diving into the dark and icy waters of Antarctica. The eerie blue darkness is enveloping you, reminiscent of the vast expanse of open space. In these depths, where you least expect to encounter any living creature, you suddenly hear a loud, strange sound. A quacking noise, as if a giant duck was hidden in the deep. In 1960, researchers first recorded this sound and named it bioduck. Clever. For decades, they tried to unravel the mystery of its source. Was it a giant kraken? An extraterrestrial spaceship that had crashed into the ocean? A mysterious sea monster? Or perhaps an enormous duck? There were many versions, one more bizarre than the other. Oceanographers detected similar sounds in other locations as well. Off the western coast of Australia and near New Zealand, they recorded similar but higher pitch signals, which they named bio-goose. It seems the creepy atmosphere of the story disappears with such names. Anyways, these sounds were not isolated incidents. They happened multiple times with consistent intervals. Many initially thought the source must be mechanical, given the regularity of the sounds. However, studying the oceans in the latter half of the 20th century was challenging because of limited technologies. Nevertheless, scientists persisted in collecting data on bioduck and biogoose, driven by their insatiable curiosity. As more data accumulated, so did the theories. But scientists eventually uncovered the mystery. Bioduck turned out to be a form of communication with a biological origin. When researchers analyzed the repeating sounds, they noticed that the signals never overlapped. One source would speak while the others remained silent, suggesting a form of communication. The question remained, which ocean creature possessed such an extraordinary method of communicating through varied frequency sounds? The answer, as many have guessed, is whales. Scientists compared the bioduck sound from Antarctica with the calls of minke whales and found striking similarities. The biogoose sounds from the waters off Australia and New Zealand likely belonged to other species or very young minke whales. This discovery, however, only deepened the mystery. What purpose did these sounds serve? Were the whales discussing their dinner plans, laughing at the humans recording their voices, or perhaps sharing deep insights about the universe? The possibilities were endless, but the most astonishing revelation was that humans might one day learn to communicate with these magnificent creatures. Communicating with whales is no longer a far-fetched idea. Scientists from the University of California have already established contact with a humpback whale named Twain. In a groundbreaking experiment, researchers conducted a 20-minute conversation with the marine mammal. Here's how they did it. The specialists went on a marine expedition to the coast of Alaska, where they recorded the sounds of a group of humpback whales. Then they played these sounds through speakers, sending the signals back into the ocean. The recorded sounds resembled a greeting, like, "Hey, what's up?" but in the whale language. These greetings are used by whales to call each other or indicate their location. Now, soon after sending the signals, the researchers received a response. Twain approached the boat, circled it, and replied with a "hey" of its own. This marked the beginning of the first ever human-whale conversation. For 20 minutes, the scientists sent 36 signals to Twain, and each time the whale responded. Moreover, it waited for time intervals before answering. That is, the team received a response from the whale, waited 10 seconds, and turned on the sound again. Researchers then waited 10 seconds and answered. It seems that Twain was a very delicate interlocutor. Maybe it was a gentleman in the whale world, who knows? Or maybe it was simply intrigued by the unusual interaction. The signals used in this communication belonged to a group of whales that included Twain. It's likely that the researchers had recorded Twain's own sounds and used them to communicate with it. In a sense, Twain was conversing with itself. Now let's continue our journey and venture into the deepest oceanic trench on Earth, the Mariana Trench. A quick reminder, the Mariana Trench is a colossal chasm in the ocean floor, stretching over 1,500 miles south of Japan and reaching a depth of nearly 36,000 feet at its deepest point. To put that into perspective, the height of the Burj Khalifa, the world's tallest building, is like 1/10 of the Mariana Trench's depth. Now imagine this. In this deep, dark abyss, scientists recorded a strange sound. Unlike bioduct, this sound resembled something from a science fiction movie, a low rumble, followed by a metallic ping, reminiscent of the sounds made by spaceships in sci-fi movies. Researchers named this mysterious phenomenon biotwang noises. Scientists first detected this strange sound in 2014 during an acoustic survey of the Mariana Trench, and they quickly identified its source: whales, specifically Bride's whales. Using artificial intelligence, researchers analyzed around 200,000 hours of audio recordings from the ocean and found matches with a group of Bride's whales. Like other animals, these whales use sounds as a form of communication. Now, did you know what else was found at the bottom of the Mariana Trench? A plastic bottle. It's unlikely it was done by a kraken or a whale or some type of monster. Everything is simpler here. The bottle ended up there because of a human. But that's a topic for another video. Okay, let's deal with one more sound. No whales this time, just a mysterious sound in the loneliest place on Earth. This place is called Point Nemo, and that's why it's so lonely. Located in the South Pacific Ocean, Point Nemo is the most remote spot from any land. The nearest island is 1,450 nautical miles away. It's about the same long distance from land in all other directions. Moreover, here, there's almost no marine life, since few water currents reach this spot, and therefore few nutrients are supplied. In a sense, it's a water desert. And so, in 1997, oceanographers recorded a very strange and frightening sound coming from the depths in the area of Point Nemo. It was something gigantic and scary. People called it the bloop. As soon as journalists found out about this phenomenon, people around the world began to invent the most fantastic versions. The most popular of them was that the sound source was a giant sea monster, kraken, or some other creature. The hype around the bloop didn't last very long. Scientists managed to find out the nature of the mysterious noise. It turned out it belonged to an iceberg. When they crack and collapse, they create powerful ultra-low frequency sounds that can be heard from a very long distance. To confirm this version, scientists recorded the sounds of other icebergs and heard something similar to the bloop. Oh, by the way, Point Nemo is so lonely that space agencies drop out-of-service satellites here. Space objects just fall in the water. There's a 99% chance that no animal or human will be harmed by falling debris in this lonely place. That's why many people call it the satellite cemetery. But what if, someday, a spaceship from another planet falls here? What if it has already fallen in Point Nemo and sometimes emits an emergency signal that breaks through the ocean? Ooh. All the mysteries you have heard have already been solved. How about we end this video with a mystery that still baffles scientists? Meet upsweep. One of the most mysterious sounds ever recorded in the ocean. It's not just noise, it's a series of short ascending tones repeated at intervals of several seconds. It was first discovered in 1991 using hydrophones installed in the Pacific Ocean. At first, oceanographers suggested that upsweep could be associated with volcanic activity or underwater earthquakes. But the seasonal nature of the sound and its intensity change depending on the time of year, which rules out these versions. People began to consider hypotheses related to the biological life of the ocean. They studied the migration routes of marine animals and their behavior at different times of the year. However, despite all efforts, the sound source has not been identified. Some studies suggest that upsweep may be associated with certain species of fish or other marine animals that make sounds for communication or navigation, but no one has been able to prove it. Well, here you are. You're getting into your submarine, feeling a bit anxious. You're going to descend hundreds of feet underwater to explore the ocean floor. So many things can go wrong. Technical issues, insane water pressure, dangerous marine monsters, mysterious eerie sounds. Wait, what? Eerie sounds so deep underwater? Yep, a strange humming noise is coming from the ocean depths. What makes it even creepier is that it only appears during dusk and dawn. This noise might act as a dinner bell, since it's likely to have a connection to massive groups of sea creatures moving up and down through the water to feed. But so far, it's just a theory. Using highly sensitive underwater microphones, researchers recorded a mysterious low-frequency hum at depths of 660 to 3,300 feet. The sound wasn't very loud, just 3 to 6 decibels above the usual ocean background noise. For comparison, when someone is whispering in a quiet library, the sound reaches 30 decibels. The underwater noise also had a puzzling or humming quality. The weirdest thing? Despite their efforts, the researchers couldn't pinpoint a single species responsible for the sound. The noise originates in a region known as the twilight zone of the ocean. This region is dark and doesn't have many nutrients, with no sunlight for photosynthesis. Life here relies on organic debris falling from above, such as deceased organisms or waste material. At the same time, while it may sound barren, the twilight zone is far from empty. A 2015 study estimated that up to 90% of the world's fish could live in this zone, including many undiscovered species. Now, back to the mysterious noise. The researchers believe the sound may be linked to the vertical migration of small marine creatures like fish, shrimp, and squid. These animals move upward toward the surface at sunset to feed on plankton and nutrients, using darkness to avoid predators. At sunrise, they return to the depths to hide. This migration, which is one of the largest animal movements on Earth, involves billions of organisms and occurs daily. Scientists suspect that the strange hum might occur during this migration. as a way for the creatures to communicate or coordinate their movements. It might also serve as a signal to indicate when it's safe for a group to go to the surface and feed. If some animals indeed use the hum to communicate, it could help us understand deep-sea life better. The Twilight Zone has always been considered a quiet environment, but such a discovery hints at complex social behaviors and interactions among its inhabitants. But it's not only the ocean that produces bizarre sounds. Earth is humming non-stop too. Unfortunately, you can't hear this soundtrack. This hum isn't from earthquakes. It's produced by subtle ongoing vibrations in the planet's crust. They're too faint for us to feel and can only be detectable with special equipment. Scientists have long known about this phenomenon called free oscillation and have recorded this persistent hum. Earthquakes are the most noticeable ground movements. According to the U.S. Geological Survey, Earth experiences about 500,000 earthquakes every year. Of those, only 100,000 are strong enough to be felt, and around 100 cause noticeable damage. But in the quieter moments between earthquakes, the planet is still constantly vibrating with smaller, unnoticeable movements. Unlike the sudden jolts of earthquakes, this hum is steady and uniform, and it's a byproduct of microseismic activity. Seismometers, tools used to record ground vibrations, can detect this sound anywhere on land. For years, researchers have been debating the origins of this hum. Some thought it came from ocean waves reaching deep into the seafloor. Others believed it was caused by colliding waves on the ocean's surface. By 2015, scientists had confirmed that both factors contributed to Earth's constant vibration. And although this hum has been recorded on land, now we also have much clearer, more detailed underwater recordings. To study the hum, researchers used spherical seismometers on the seafloor in the Indian Ocean near an island east of Madagascar. Between September 2012 and November 2013, they placed 57 freefall seismometers across a 772 square mile area. These devices are designed to sink into the ocean floor and record even the faintest vibrations. Over the course of the 11-month study, the team filtered out noise from ocean waves and seafloor currents. They got clear, consistent signals of Earth's hum, with peaks at frequencies between 2.9 and 4.5 MHz, far below the range of human hearing, which starts at 20 Hz. The discovery of Earth's hum from the ocean floor is more than just a scientific curiosity. It gives researchers a new way to study how energy moves through the planet's crust and mantle. In any case, the world around us is filled with weird sounds that sometimes remain unexplained. One of the most intriguing examples is the bloop, an incredibly loud underwater sound recorded in 1997 by the U.S. National Oceanic and Atmospheric Administration. The sound lasted about a minute and began as a low rumble, which then increased in frequency. It was so loud that underwater microphones detected it across an astonishing 3,000 miles. Initially, some experts thought it was the call of a massive unknown sea creature. However, NOAA later determined that the source likely had been the calving of icebergs, when giant pieces of Antarctic glaciers had been breaking off and crashing into the sea. The sound, known as Julia, a strange cooing noise, could have been produced by an iceberg scraping along the ocean floor. Another sound, dubbed train, due to its resemblance to the sound of train wheels on a track, likely originated in Antarctica's Ross Sea. Then there is upsweep, a recurring seasonal scratchy noise detected in the Pacific Ocean since 1991. Despite years of research, its exact cause remains unclear. The underwater world also has bizarre sounds that can be described as choirs of fish. Scientists studying marine life off the coast of Port Hedland in Western Australia discovered that many fish species sing in synchronized choruses at dawn and dusk, much like birds. Over 18 months, researchers recorded tons of sounds, including foghorn-like calls from black jewelfish and rhythmic ba-ba-ba sounds from batfish. These fish songs, which often involve repetitive calls that overlap in large groups, are especially important for breeding, feeding, and territorial behavior. Deeper in the ocean, NOAA researchers also explored the sounds of the Challenger Deep, the deepest part of the Mariana Trench. They used a titanium-encased microphone that managed to survive the crushing pressure, over 1,000 times the atmospheric pressure at sea level. Over 23 days, the recorder captured loads of noises, from the haunting songs of whales to the rumble of distant earthquakes. Now, we've already figured out that the ocean is filled with strange sounds, but you can also hear weird noises above ground. One of the most puzzling is the hum, a low-pitched noise reported by people in specific areas, such as Taos, New Mexico, or Bristol, England. The sound is often described as a faint engine-like drone, and its source remains a mystery. Some researchers think it might be a psychological phenomenon, where people focus on subtle background sounds they might otherwise ignore. In any case, no definitive answer has been found yet. Geological formations can sing too. Utah's Rainbow Bridge, a massive 300-foot-high sandstone arch, vibrates like a guitar string when exposed to sounds, distant earthquakes, or waves near Lake Powell. Scientists have studied its frequencies to understand how such vibrations could affect the bridge's stability over time. Interestingly, visitors to the Rainbow Bridge have reported hearing faint humming sounds too. The skies also have their own eerie noises. For centuries, people in polar regions have described faint sizzling, popping, and cracking sounds, accompanying auroras. A Finnish researcher made the first known recordings of these sounds and traced their origin to electrical discharges in the lower atmosphere, about 230 feet above the ground. These charges, caused by magnetic storms fueling auroras, produce faint sounds during calm and clear nights. Other natural phenomena, such as icebergs grinding against the seafloor or volcanic activity on the ocean floor, produce groans, rumbles, and crackling sounds that scientists study to learn about glacial movements and underwater geological activity. I myself produce many unusual sounds and rumbles, but, that's a subject for another video, or my next annual review.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank one bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But, to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for two main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? or how much of it is actually usable as a water resource. Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia Subduction Zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones: the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
You know, oceans cover around 70% of Earth's surface, and we have only explored 5 to 20% of them. And now, astronomers have found more water, a huge stash floating out there in space by a quasar that's more than 12 billion light-years away. And we aren't talking about just a little puddle. It's a mind-blowing amount of water, about 140 trillion times more than all the water in Earth's oceans combined. It's hanging around a supermassive black hole that's a staggering 20 billion times bigger than our Sun. This black hole is surrounded by a super bright quasar. It gives off as much energy as you get if you gathered 1,000 trillion suns. I can't count that high. Oh, by the way, since light takes time to reach us, we're seeing this quasar as it was when the universe was still very young. Astronomers are sure that the newly discovered water reservoir is the farthest and biggest we have ever found in space. Mark Bradford from NASA's Jet Propulsion Laboratory explains that the environment of this quasar is so unique that it's capable of creating an incredible amount of water. Bradford's team, along with another group of astronomers, has been studying the quasar and the supermassive black hole at its center for quite some time. They've noticed that as the black hole pulls in surrounding matter, it heats up the nearby gas and dust. This process has created a region packed with molecules that have never been observed at such a great distance before. Now, quasars were first spotted around 50 years ago, when telescopes picked up super bright objects way out in space. They're not regular stars. They shine from the centers of distant galaxies and are so powerful they outshine all the stars in their galaxy combined. At the heart of every quasar is a gigantic black hole, which is millions or even billions of times heavier than the Sun. When gas and dust swirl toward the black hole, they heat up and release an insane amount of energy. It makes quasars some of the brightest and most powerful things we've ever seen in space. Looking at quasars is like looking back in time. The light we see from them today has been traveling for billions of years. It gives scientists a peek at what the universe looked like way back in the past. Quasars can help us understand how galaxies formed, how matter spread out, and how the first cosmic structures came together. Some quasars shoot out massive jets of superfast particles. Stretching across space, they can sometimes change entire regions of the universe. But let's get back to that space water, or rather water vapor. When astronomers discovered it, it was floating around the quasar, spread across a huge area hundreds of light years wide. For comparison, just 1 light year is about 6 trillion miles. Even though the gas there is incredibly thin, unlike what we're used to on Earth, it's much warmer and denser than the gas found in most other galaxies, including our own Milky Way. The temperature of this gas is around minus 63 degrees Fahrenheit, and it's about 300 trillion times less dense than Earth's atmosphere. It does sound extreme, even in space terms, it's unusual. Now, water vapor isn't just another molecule. The very fact that it exists near the quasar hints that the area is regularly blasted with radiation. That's what keeps the gas warmer than usual. To add to the mystery, astronomers also found carbon monoxide and other molecules. In other words, there's plenty of raw material floating around. In the future, this gas could help the supermassive black hole grow even bigger, up to 6 times its current size. But that's just one of many potential scenarios. Some of the gas might get pulled into the black hole, some could form new stars, and some might even get flung out into space. Now, finding water vapor in such a distant quasar means that the basic building blocks of the universe have been around for billions of years. Water is crucial for life as we know it, so its presence so long ago hints that the ingredients for life existed much earlier than we might have thought. But water isn't just important for life. It also plays a key role in how stars and galaxies form. When giant clouds of gas cool down, water helps them collapse, making it easier for new stars to be born. But how did researchers even spot this massive cloud of water? In 2008, Bradford's team started looking for water in space with the help of a special instrument called Z-spec. It was attached to a 33-foot telescope in Hawaii. To double-check their findings, they used another powerful tool, CARMA. That's a group of radio dishes in the mountains of Southern California. At the same time, a different team was searching for water using a telescope in the French Alps. In 2010, the second team found a small hint of water in the distant quasar. It was just one teeny tiny signal. After that, Bradford's group detected more signals. It was all the proof we needed to conclude that an enormous amount of water was actually out there. Now, our floating cloud of water vapor isn't the only place where we've found water beyond Earth. Scientists have recently made a huge discovery. It turns out there are massive reserves of liquid water hidden deep underground on Mars. So, in theory, future astronauts could use this water to support missions or even make Mars a long-term home. But of course, there's a catch. This water isn't sitting in nice, accessible lakes or oceans. It's buried so deep inside Mars that we have no way of reaching it with current technology. Scientists have figured this out by analyzing seismic data from the Mars InSight lander. It picked up some strange seismic activity, and the best way to explain it is by these hidden water reservoirs. Mars still does have some water today, mostly as ice on or just beneath the surface. But that's nothing compared to the massive amounts of water the planet had billions of years ago. The big mystery is, where did all that water go? Scientists think it could have either escaped into space or moved into the planet's interior, where it might now be trapped as liquid reservoirs or ice deposits. The problem? We have no way of measuring how much water Mars lost. So for now, that question remains unanswered. Earth's moon has water too, but not in the way you might think. Instead of lakes or rivers, the moon's water is mostly frozen ice, spread out unevenly across the surface. The cold, shadowed poles are especially full of it, since they never get sunlight. A lot of this ice is also mixed in with lunar soil and buried deep underground, making it super tricky to get to. Then there's Enceladus, one of Saturn's moons. It's tiny, just 314 miles across. It's small enough to fit inside Arizona. I think we should try that. Anyway, when NASA's Cassini space probe arrived at Saturn, scientists expected Enceladus to be a barren, frozen world. But instead, they saw huge plumes of icy particles and water vapor erupting from geysers near the South Pole. That meant there had to be a massive ocean hiding beneath its icy shell. sandwiched between the moon's rocky core and the frozen surface. The fact that this ocean is active and constantly sending material into space makes Enceladus a top candidate for future exploration. We also have Europa, one of Jupiter's moons, and one of the most promising places to search for alien life. Europa has a gigantic saltwater ocean that could be 40 to 100 miles deep. This means it might hold more water than all of Earth's oceans combined. But there's a big obstacle. This ocean is hidden under a thick ice shell, which scientists think is 10 to 20 miles deep. Europa's ocean stays liquid because of tidal forces from Jupiter's gravity. The planet's massive pull stretches and squeezes the moon, creating friction, which heats up the interior, stopping the ocean from freezing solid. And the most exciting part is that scientists think water plumes might be erupting from cracks in Europa's ice, shooting ocean water into space. Now, if that's true, we could potentially sample the ocean without having to drill through miles of ice. But there are still a lot of unknowns. How big are Europa's water reservoirs? How quickly do they refreeze? And how does the intense temperature and pressure affect the ice? Scientists are eager to figure this out because Europa's ocean is one of the best bets we have for finding extraterrestrial microbes somewhere in our solar system. Okay, it's pop quiz time. What's the strongest river in the world? The Amazon? Pfft, rookie guess. No, really. The mightiest river isn't on land at all. It's underwater, and it's called the Antarctic Circumpolar Current, or ACC for friends. This beast flows with a force 100 times stronger than the Amazon River, and it could power over 100,000 hydroelectric plants. That's enough electricity to light up entire continents. But this underwater juggernaut doesn't just flex its muscles for fun. It's the planet's ultimate multitasker. The ACC is Earth's thermostat, carbon vacuum, climate stabilizer, and oceanic superhighway all rolled into one. But here's the not-so-fun part. Scientists have spotted a serious red flag. The ACC is slowing down. And not just by a little bit. We're talking up to 20% weaker by 2050. If this trend continues, we're looking at climate chaos that could make your worst Monday feel like a day at the spa. So, maybe time to panic a little? Well, hold on. So what is the ACC anyways? To learn more about it, we need to dive deep into the ocean, figuratively. The Antarctic Circumpolar Current is the only ocean current that flows all the way around the planet, hugging the cold continent of Antarctica like a belt of water. Unlike other currents that get tripped up by continents, the ACC has a clear racetrack, nothing but open ocean, so it flows uninterrupted through the Drake Passage between South America and Antarctica. It moves an astonishing 3.6 billion cubic feet of water per second. That's so much water we couldn't find anything to compare it to, sorry. The ACC is driven by ferocious westerly winds, moving eastward to connect the Atlantic, Pacific, and Indian Oceans into one continuous supercurrent. It also plunges into abyssal depths, connecting shallow, intermediate, and deep waters into one giant, swirling blender of oceanic energy. Now, to put it simply, maybe too late for that, but I'll try, the ACC is the glue that is keeping all of our planet together. It plays a starring role in the thermohaline circulation, or global conveyor belt, if you don't want to sound lame. This is the system that redistributes heat, carbon, and nutrients around the globe. To make it all work, the ACC pushes nutrient-rich deep water to the surface in a process called upwelling, feeding plankton, krill, whales, and eventually sushi on your plate. That means if you love seafood or care about ocean food chains at all, you should really start paying attention. Without this nutrient cycling, marine life from the bottom to the top of the food web suffers. Now, here's the cool part. While it's busy playing waiter to the sea, the ACC is also doing our laundry. Well, sort of. It absorbs massive amounts of carbon dioxide from the atmosphere and stores it in the deep ocean, locking it away for centuries. Think of it like Earth's giant carbon vault, no password required. It also helps regulate the weather. Without the ACC pushing heat around the globe, Western Europe would be 50 degrees colder. That means Paris would feel like Siberia, and Londoners would have to trade their umbrellas for snowshoes. The current helps maintain the temperature balance between the hemispheres, stabilizing wind patterns, rainfall, and ocean temperatures around the world. Even hurricane patterns could change because warm ocean surfaces are a key ingredient for cyclone formation. Mess with the currents, and you might be dialing up stronger, weirder storms. So, why is it slowing down? Well, of course, the answer is humans. You know those ice caps that are melting? Well, in Antarctica, where our friend the ACC lives, there's so much ice that if all of it melted, the Earth would rise more than 200 feet. That's taller than Cinderella's castle. What's worse, 60% of all the fresh water in the world is frozen in that ice. While that much water melting is already terrifying, it's the freshness of the water that really messes things up. You see, the ACC relies on the Southern Ocean's cold, salty water to be dense and heavy so it can sink, which helps power the current forward like a chain reaction. But when fresh water from melting glaciers pours into the ocean, it dilutes the saltiness. That makes the water less dense, so it stops sinking properly. Without that sink and flush mechanism, the ACC can't maintain its powerful flow. It's like trying to flush a toilet with no gravity. As this continues, fresh water flows north, altering the ocean's density structure and counteracting the effects of ocean warming, which normally would speed the current up. Instead, the ACC slows down. A weaker ACC means less upwelling, so fewer nutrients reach the surface. This could devastate Antarctic marine ecosystems, reducing biodiversity, collapsing fisheries, and threatening species like penguins, whales, and krill. It also opens the door in Antarctica to invasive species, like the southern bull kelp, which could throw entire food chains into chaos. Krill alone are the main food source for whales, seals, penguins, and fish. So when krill populations crash, the whole system begins to wobble like a house of cards in a hurricane. And then there's the feedback loop from hell. As the ACC weakens, more warm water can sneak southward, reaching Antarctica and melting the ice even faster. That melting will dump more fresh water into the ocean, which will weaken the current even more, which will melt more ice, and you get the idea. It's a vicious cycle. Worse still, warm waters underneath ice shelves can cause them to break apart from below, meaning the melting accelerates even when surface temperatures seem stable. Globally, the effects would ripple far and wide. Monsoons in India could become erratic, rainfall in the Amazon could drop, and agriculture from Africa to Asia could suffer. Sea levels along the east coast of North America could surge, and global weather patterns could spin into confusion. Even the Southern Ocean's ability to support commercial fisheries, like Chile's lucrative salmon industry, could decline as nutrients fail to reach the surface. And let's not forget, without a strong ACC, the ocean's ability to absorb carbon and excess heat plummets. That means that more CO2 and heat will stay in the atmosphere, making our lives even more miserable. It's like turning off Earth's air conditioner while cranking up the furnace, and burning down the pantry while you're at it. Of course, this isn't the first time things went south with the ocean currents. Before humans started heating up the planet, Earth went through a deep freeze called the Little Ice Age, and it wasn't just about colder winters. This icy chapter may have kicked off when ocean currents in the North Atlantic started acting weird. And it wasn't so long ago. This Little Ice Age had a peak in 1850, literally yesterday. Scientists believe that melting glaciers and massive exports of Arctic sea ice flooded the ocean with fresh water. That fresh water messed with the ocean's usual saltiness and density, weakening powerful systems like the AMOC, short for Atlantic Meridional Overturning Circulation. That's a mouthful. It's another crucial piece of the global conveyor belt puzzle. As these currents slowed down, less warm water reached the north, sea ice spread farther, and temperatures dropped even more. And here's the spooky part. Records from seashells near Iceland showed that this shift didn't happen all at once. It came in two waves, like the planet was struggling to stay stable before tipping into a colder world. And because the AMOC is also part of the crazy life support system of planet Earth, everything is connected. Both systems are influenced by temperature, salinity, and the sinking of cold water. When the ACC slows, it can alter the balance of deep water formation and mixing, potentially weakening the AMOC too. That's a domino effect you really don't want to see. In fact, some models suggest that if both the ACC and AMOC are pushed past their tipping points, the result could be centuries of unstable climate conditions, way beyond anything modern agriculture or infrastructure is built to handle. So, next time you're sipping a cold drink or enjoying sushi, maybe raise a toast to the mighty ACC. It's doing a lot more for you than you think, and it could really use a little appreciation and less ice melting, please.
Hey, don't freak out. Those red waters you see aren't blood oceans. It's just a natural occurrence called the red tide. Red tides often happen in Florida, especially in the West Florida shelf, and they can stick around for weeks or even months. They're basically caused by an increase in algae levels, hence the color. Those algae produce toxins that can be harmful to marine life. They can also be bad news for us humans, causing symptoms like upset stomach and urgent bathroom trips, if you're picking up what I'm putting down. Volcanoes are super scary, but there's nothing scarier than getting taken out by a pyroclastic flow. These fiery flows move crazy fast and reach insane temperatures, like hotter than your oven on a pizza night. They're like a fireworks show of volcanic eruptions filled with ash, lava, and hot gas, speeding down mountains at 50 miles per hour. Some researchers claim they might even hit speeds of 450 miles per hour, almost as fast as a passenger jet. If you're unlucky enough to be in the path of a flow, you're in big trouble. The heat alone can turn you into a human barbecue, even if you try to hide in a building. The air around the flow can reach temperatures high enough to fry your insides, burn your clothes off, and leave metal melted into your skin, which almost sounds like a Marvel origin story. However, a lot of people have met their end because of these flows. But there's one crazy story about a guy named Luger Silbaris, still sounding like an origin story. So on the 7th of May, 1902, there was a major eruption on the island of Martinique. The night before, Silbaris had gotten into trouble and ended up in jail. Maybe this is a villain origin story. He'd been locked in a sturdy cell facing away from the volcano. The next morning, Mount Pella unexpectedly erupted, destroying St. Pierre within minutes. The flows wiped out around 30,000 people, but Silbaris survived in his cell and became known as the guy who lived through doomsday. The rescue team found him 4 days later. By the way, the cell still stands today. I hope somebody tested him for superpowers. Back on August 21st, 1986, a guy stumbled upon some animals showing no signs of life on his way to Nios village in Cameroon. To his shock, he later found out that everyone in the village had mysteriously passed away. The same thing happened at Lake Manaun in 1984. Turns out, those tragic incidents were caused by something called limnic eruptions, which are pretty rare disasters where carbon dioxide suddenly bursts out of lake waters, creating a hazardous gas cloud. These type of eruptions usually happen in lakes with high levels of CO2, which can be caused by things like volcanic gases and high pressure. Any little change in temperature or pressure can set off an eruption. So, experts have started looking into ways to safely release CO2 from lakes like Manaun and Nios in order to lower the risk of more disasters in the future. In March 2024, a video captured a terrifying moment of a woman disappearing into a sinkhole while browsing through a Chinese department store. Guess she got more than she bargained for. Ha ha ha. Moving on. The scene unfolded as the floor beneath her gave way, sending her plummeting into the abyss. In the midst of the chaos, another customer frantically ran away before returning to check on the woman who had fallen. Their quick thinking and the swift response of emergency crews and firefighters saved the day, resulting in only minor injuries for both women. I'm glad that lady checked on her because I would be gone. An anvil cloud is basically a big cloud made of ice particles that forms at the top of really tall thunderstorms, or those huge cumulonimbus clouds. The flat top shape is caused by the air rising in the storm and spreading out when it hits the stratosphere. That's why it's called an anvil. It looks like the tool metal workers use. Duh. The air from the anvil cloud is cooler than the stratosphere air, which keeps it from going any higher. You can spot anvil clouds from really far away, sometimes over 100 miles. Often you might see streaks of snow coming from the edge of the cloud, known as virga. The snow disappears before hitting the ground because of the dry air. If you notice clouds poking through the flat top or bubbling up, it's an overshooting top, a sign of a super strong storm. Anvils are known for producing dangerous lightning. Normally, lightning comes from the bottom of a storm, but anvil clouds can produce really powerful lightning from the top. This lightning can strike out of nowhere, even from up to 30 miles away. So keep an eye on those anvil clouds if you see one forming nearby. Lahars are no joke. They're basically fast-moving, super dangerous streams of rock, ash, and water that come down the slopes of volcanoes. It's important for everyone to be aware of them. Scientists, policymakers, and even us regular folks. By understanding how lahars work and their potential impact, we can try to stay safe when volcanoes start acting up. Saving lives during natural disasters is the name of the game. There are two main types of lahars: debris lahars and mudflow lahars. Debris lahars are full of solid stuff like rocks and ash, while mudflow lahars are more waterlogged and sludgy. Lahars can be triggered by the rapid melting of snow or ice, heavy rain falling on loose volcanic material, or even a crater-like eruption. The volcano's characteristics and presence of water are key factors in how lahars form and move downhill. When lahars come barreling down mountains at speeds of up to 120 miles per hour, carrying loads of debris, it's a recipe for disaster. Unless you have a surfboard, but I doubt you'll have a surfboard on a volcano. Just saying. Also, it won't work. Going to the beach for a sunny vacation is the best. There's nothing like basking in the sun, feeling sand between your toes, and hearing waves crash against the shore. But even though it's all relaxing and picture perfect, always keep an eye on the water and never turn your back on the ocean. You may know about rip currents and tides, but have you ever heard of square waves? It's a real thing, and it can be pretty scary. Square waves, also known as cross seas, happen when two swells meet, forming a unique square pattern that looks like a checkerboard. They can be found along coastal areas, and while they are rare, they can create waves up to 10 feet high and make it tough for boats and swimmers to maneuver. If you find yourself in the water with square waves, you might feel like you're fighting against two different currents. The best thing to do is to not go too far out to begin with, and get out of the water as soon as the waves become too strong. Square waves are more dangerous for boats and ships, so it's best to stick to the shallow waters and stay safe. Whirlpools and maelstroms are powerful natural forces that have scared sailors for years. They happen when certain weather and current conditions come together just right. Most of them are safe if you stay away, but let's see what they really are and how they form. A whirlpool is basically water that starts spinning when two currents meet, or one current hits something solid like a wall. They can be big or small, depending on the speed of the water and waves. Most aren't dangerous, but there are also maelstroms, which are large, forceful, and violent whirlpools, caused by ocean tides and narrow straits. Tidal currents in places like Norway's Saltstraumen and Moxstraumen can create massive whirlpools. Scotland's Corryvreckan whirlpool is one of the world's largest. Other examples of whirlpools can be found in Japan, Canada, and New Zealand. Are they portals? They're definitely not portals. Researchers have recently looked into ancient underwater volcanic eruptions and how they affected Earth's climate. They studied materials from Bronze Age eruptions to learn more about their scale, dangers, and impact on climate. For example, one eruption about 3,600 years ago in the Aegean Sea caused chaos in Santorini. The study focused on this event to understand its importance. By analyzing volcanic deposits, the researchers gained insights into how future eruptions could affect climate. They discovered that sediment waves from shallow underwater eruptions could lead to tsunamis and impact the ocean floor. These findings help us understand how underwater volcanic eruptions relate to the marine environment, which can help us predict climate changes in the future. You know how they say it's better to just hand over your wallet if you run into a mugger? Instead of surrendering their wallets, sea cucumbers choose to spit out some of their insides to fend off predators like crabs and fish. It's a natural defense mechanism for them, and they quickly grow those organs back in just a few days, thanks to special cells inside their bodies. It's not the only weird thing sea cucumbers do. They can actually breathe through their rear end. They have this thing called a respiratory tree that connects to their backside and sits right next to their intestines. So when they suck in water from their behind, it goes into that respiratory tree, letting them absorb oxygen directly into their fluids. Plus, sea cucumbers are the janitors of the ocean. They munch on whatever gets stuck in the sand on the ocean floor. Once they've eaten, they manage to clean out the sand, leaving it nice and tidy after they do their business. As for the clean sand, the stunning white sand beaches in Hawaii are actually a product of parrotfish number 2. These fish munch on algae from rocks and dead corals, and while they're chomping away, they also grind up the leftover bits of coral in their bellies. When they're done, they move their bowels, and voila! It all comes out as beautiful sand. Not only do they play a vital role in keeping the coral reef ecosystem healthy, but they can churn out hundreds of pounds of this white sand every year. Marine animals are seriously impressive when it comes to holding their breath. Just look at sperm whales and elephant seals. They can stay underwater for a mind-blowing 2 hours. Then there's the Cuvier's beaked whale, which holds the crazy record at almost 4 hours underwater. When you compare that to the human record of 24 minutes and 37 seconds held by pro diver Budimir Shobat, it seems pretty insignificant. But what's the marine animal's secret that helps them excel humans this much? Unlike us, these sea creatures have a ton of hemoglobin and myoglobin in their blood and muscles, allowing them to store way more oxygen. When their oxygen runs low, myoglobin steps up and releases even more. Plus, they can tolerate higher levels of CO2, so they don't feel the need to breathe as quickly. There's even a study that found their myoglobin molecules have a unique charge that keeps them from sticking together, which boosts oxygen storage. And on top of all that, they can slow down their heart rate and restrict blood flow to hang out underwater even longer. Rumor has it that about 540 million years ago, a meteor loaded with frozen octopus eggs smashed into Earth. Sounds like a delirium, but some scientists are entertaining a very questionable idea that octopuses and their cephalopod buddies, like squids and cuttlefish, might actually have some extraterrestrial origins. The thing is, cephalopods have extraordinary DNA that doesn't look like any other DNA on our planet. They've got around 33,000 protein-coding genes in their genome, which is way more than what we humans have. A recent study suggests that their evolutionary story shows some odd traits that might hint at a connection to space, like they could be from some super far-off past, or even the future. The researchers went as far as to claim that modern octopuses could be the descendants of these frozen creatures that hitched a ride on comets and splashed down in our oceans. And why octopuses? Well, they really stand out in the animal kingdom. They can use different tools to build their own houses, and they can even solve everyday problems independently of their brain, as 2/3 of an octopus's neurons are in its arms. These traits seem to have just appeared out of nowhere during evolution. They even tossed around another quirky theory. What if an extraterrestrial virus crashed into early squid populations and gave them a crazy boost in evolution, turning them into the octopuses we know today? Anyways, these are just fun speculations without any hard proof. Now, this funky object is an animal, not a rock. It's called sand dollar. Just look at the shape of its shell. Once sand dollars are exposed to the sun, their shells lose their soft, spiny covering and become bleached white. Back in the day, beachcombers thought these shells looked a lot like big silver coins, kind of like the old Spanish dollar that was about the same size. but if you prefer, you can call them sand cakes instead. These quirky creatures have tiny spines on their surface, and they glide along the ocean floor. They use small tube feet that line the grooves on their underside to grab bits of food like plankton and algae, which they then send to their mouths. Inside, they have 5 triangular teeth that help them munch on their meals. In some Georgia folklore, sand dollars are said to represent coins lost by mermaids. Sand dollars have a unique talent for cloning themselves. They can do this for a bunch of reasons, like when a predator comes around. Some species of sand dollar larvae can actually split in half as a defense mechanism. It takes about 24 hours for them to clone themselves, and the new larvae end up being about 2/3 smaller than the original, which helps them hide from danger. Wait, is that a giant sea hot dog racing through the ocean? Sorta. Some scientists have joked that sperm whales seriously resemble enormous hot dogs. These massive creatures can take quick naps, standing up for about 10 to 15 minutes. They only sleep about 7% of the time, mostly between 6 p.m. and midnight. Sperm whales also have a cool ability to retract and extend their eyes, thanks to a thick retractor muscle around them, but they can't actually roll their eyes in their sockets. Plus, they have the most asymmetrical skull of any mammal out there. Oh, and let's not forget, they have the largest brain of any living creature, weighing in at over 9 pounds. Unlike us humans, if dolphins went into full-on snooze, they'd stop breathing and could drown. So they figured out a genius solution. They let only one side of their brain sleep at a time. This means one half stays awake to keep them breathing and watching out for any potential threats. When they snooze, they only close one eye. If their right brain is resting, their left eye is shut, and vice versa. This unique sleep style is called unihemispheric sleep, and it lets them recharge without ever fully losing awareness. On top of that, dolphins might be using corals and sponges like their own little pharmacies. Scientists have seen them rubbing their bodies against specific types of coral and sponges, suggesting they might be treating skin issues. They've even spotted dolphins lining up to take turns at these spots, using corals like Gorgonian coral Rumphella aggregata, leather coral, and some sponges. What's really fascinating is that researchers have analyzed these corals and found they contain compounds that could help with dolphin skin conditions, which can sometimes lead to infections and lesions. Now, the big question is figuring out exactly how each type of coral helps dolphins, and if it really boosts their health overall. Sea urchins aren't exactly the Usain Bolts of the ocean. They move slowly by crawling with their tube feet and occasionally give themselves a little push with their spines. These little guys have just 5 teeth, which they use like a beak to scrape algae off rocks, which I'm pretty sure is the ocean's version of an all-you-can-eat buffet. But since all that scraping wears their teeth down, they're in a never-ending dental replacement program. Scallops are the underwater equivalent of the world's most confused security cameras, sporting up to 200 tiny eyes on their shells. These eyes are high-tech. They can even adjust their pupils to light. Instead of working like ours, scallop eyes have a unique setup. Light goes through a pupil, lens, 2 retinas, and then hits a mirror made of guanine crystals that reflects it back. Scientists were puzzled about how they see since their main retina often gets blurry light. But it turns out, scallops can change their pupil size by about 50%. Just don't expect them to do it in a hurry, as it takes a few minutes.
Now here's something really neat about orcas. They're expert hunters, and they do it in groups called pods. A pod can consist of up to 40 orcas, forming a very effective hunting team. Interestingly, there are distinct types of pods, resident and transient. Resident pods are more into fish, while transient pods have a taste for marine mammals. But no matter what type of pod they belong to, all orcas have one thing in common: they are master collaborators. They work together using smart hunting techniques that are often compared to the teamwork of wolf packs. Almost 95% of jellyfish's body is made of water. For comparison, the human body is 60% water. It's probably not a surprise since jellyfish don't have a heart, blood, eyes, or brain. The other 5% of their body weight is proteins, muscles, and nerve cells. Jellyfish have been around for more than 500 million years. This makes them older than dinosaurs. These creatures haven't changed much, and today's jellyfish are pretty much like their ancestors. Electric eels have small eyes that are not so effective in environments with no light, so they mostly rely on their electric organs. Those consist of 6,000 cells. Eels use them to stow power, similar to batteries. These creatures use electricity like bats use their radars or dolphins their sonar. An eel can also produce enough electricity to power a panel of light bulbs. There's a small tropical archer fish that can learn to recognize human faces. This fish has an interesting ability to spit small jets of water from its mouth. Researchers showed the fish the image of two different faces placed side by side. One was unknown and the other was familiar. The fish was supposed to spit water at the familiar one. The creature took the right guess more than 80% of the time. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. Iguanas use their long claws to hold onto the bottom when they need to graze. Green turtles can cross over 1,400 miles when migrating. They try to find the perfect spot to lay their eggs. Penguins sort of fly when they're underwater, reaching a speed of 25 miles per hour. More than 5 million years ago, I've heard, I wasn't around then, deep-sea worms and humans had a common ancestor. So we still share 70% of our genes with these creatures, and with sea stars, squid, and octopuses. Now, octopuses are in fact incredibly old. The oldest known fossil belongs to an animal that lived almost 300 million years ago. FYI, this is before our dinosaur buddies roamed the Earth. Wait, there's more! Octopus arms have a mind of their own. That's because 2/3 of their neurons lie in their arms, not in their heads. This means that their arms can problem solve how to open a shellfish, while their owner is worried about other stuff entirely. Talk about ninja-level multitasking. Oh, and like other animals, such as chimpanzees and dolphins, octopuses have proven to be good at maneuvering tools, like picking up old shells and using them as a temporary home. Now, of course, the most intelligent animals on our planet are humans, according to humans. But we don't seem to give pigs enough credit. Pigs are so smart they can play video games. No, not Minecraft. But in a recent academic study, scientists had 4 pigs play a joystick game. They had to manipulate the stick so that the moving ball would hit the wall and then they would get a treat. All 4 pigs did great in the test, which was surprising even to the scientists. Now, pigeons also aced an impressive test. They were trained to differentiate a Picasso painting from a Monet one, which they had no trouble learning. Then they were able to apply this knowledge, identifying works of art they had not previously seen, meaning they really understood the difference between each painter. Poor things are always seen as a nuisance. Now, if we placed kangaroos in an animal's most amazing ability contest, they'd win. It's mainly because they break the 4-legged rule. A special species of kangaroo, the red kangaroo, uses its tail to help propel it forward. Now, visually, it has 4 limbs, but in practice, it uses 5. They're biologically built to use their tail as a fifth limb, since it's packed with articulated vertebrae and thick muscles. Of course, it had to be an Australian animal. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey. Now meet this guy. Unlike what its name might suggest, the red panda is closer to a raccoon than it is to a giant panda. You'll find a lot of these cat-sized creatures in the Himalayan region, hopping from tree to tree and bundled together trying to keep warm in the harsh weather. They're gentle and friendly like their big panda cousins, and occasionally enjoy eating some bamboo sticks. And then there are bees. Compared to humans, bees' brains are the size of pinheads, yet they are capable of astounding things. Let's say a bee is running low on energy after a long search flight. This bee desperately needs a drop of honey in order to continue flying, but smartly enough, she doesn't need to go back to the hive to recharge. She can ask a fellow beehive mate for a drop of honey directly from this other bee's stomach and continue flying. This type of decentralized system allows them to build highly effective societies, one that bees don't need to push to the queues in front of the honey cells, for example. Every year in the winter, great white sharks that live along the California coastline disappear. It feels as if they take a vacation for 30 to 40 days. The animals go to a point halfway between Hawaii and Mexico. They might do it to get some food, relax, or hang out with their buddies from other areas. The spot is now called the Whale Shark Cafe. Some types of sharks, like makos, whale sharks, or white sharks, breathe in a very specific way. It requires them to swim all the time. They also need to move quickly and with their mouth open. This way, the oxygen can enter and reach their gills. Sea sponges are some of the most primitive animals. They're immobile, don't have a mouth, eyes, bones, brain, heart, lungs, or any other organ whatsoever. And still, they're alive. There's such a thing as a sea unicorn. That's an animal called the narwhal. Its horn is actually a tooth that can grow up to 10 feet long. Manatees, also known as sea cows, are distant relatives of elephants. Their weight can go up to 1,000 pounds. These creatures are vegetarian and need to eat around 10% of their total weight on a daily basis. That's lots of sea salad. In some cases, manatees share space with alligators, but they get along pretty well. You can even find a photo from Florida where an alligator rides a manatee's back. Frogfish have special fins that help these creatures walk along the sand. They're very useful in shallow waters. A ghost pipefish is hard to see, but once you spot it, you're bound to get really surprised. Its head makes up over 40% of its body. Crabs don't feel like wasting time on such formalities as putting foods in their mouth. That's why they taste it with their feet, which is where their taste buds are. Marine iguanas are the only lizards on our planet that like spending time in the ocean, even though they mainly live on land. They're herbivores that feed in shallow waters and swim like snakes. There's something known as the orange cat behavior, and apparently it's not just a meme. So far, scientists have been able to understand that coat color is connected to a feline's gender. And since orange is an X chromosome, orange cats are usually males, like Garfield. The so-called orange cat behavior describes ginger cats as agents of chaos. Again, pretty much like Garfield. However, there haven't been any conclusive studies on whether coat color and cat behavior are truly linked. In terms of vision, mantis shrimps probably have the most psychedelic vision out of all animals. These funny-looking creatures have a whopping 16 varieties of photoreceptors, with 5 of them reserved for the ultraviolet or UV spectrum. Ultraviolet rays are really short wavelengths, which are invisible to humans. The thing science still doesn't understand is how exactly these mantis shrimp view the world around them. Sure, they can perceive a bunch of colors, but they can't necessarily distinguish all of these colors among themselves. It can be that they just see a lot of really vivid, really blurry colors, but we haven't figured out a way to check that out. Now, to say sloths are cute is an understatement. They may be one of the friendliest animals in the jungle, but there's more. If you look closely at their fur coat, you'll notice hints of green. These greeneries are actually tiny little algae that grow alongside sloths. They help sloths to camouflage better in the jungle, but they also nurture them. The little cracks inside a sloth's fur create the perfect environment for algae reproduction, and scientists have found species of algae that don't exist anywhere else in the world. They do get by with a little help from their friends. Deep within the Sahara Desert, you'll find a little creature known as the fennec fox. This huge-eared animal adapted perfectly to survive in its hostile environment. The huge ears help them to dissipate the unbearable heat of the desert, as well as help them to hunt for underground prey.
The snowpack over your head splits in two right in front of your eyes and starts tumbling down in the frozen slope to its resting place far, far below. Anything in its way is crushed under the immense mass of snow and debris. You're witnessing an avalanche, one of the most dangerous natural disasters. But what if I tell you about another kind of avalanche, no less blood-chilling than the mountain one? And the most bizarre thing about it is that it occurs underwater. Underwater avalanches are powerful and disastrous natural phenomena, often much more dangerous than land ones. They have the potential to wreak havoc on the entire planet, leading to catastrophic consequences. The most alarming thing? They occur all the time under the surface of the ocean, impossible to see, predict, and extremely difficult to measure. Such avalanches can get 100 times larger than land ones, and they pose a great risk to the world's communications, capable of leaving the entire planet without the internet. But we'll talk about it a bit later. First, let's go 60,000 years back into the past. We're near the northwest coast of Africa, ready to witness the colossal scale and devastating impact of a ginormous underwater avalanche. It started as a quite small underwater landslide in the Agadir Canyon. At first, it was just 0.35 cubic miles of material, but in no time, this mass increased more than 100 times in size while traveling across the Atlantic Ocean floor. As the avalanche sped up and grew, it picked up gravel, sand, rocks, and mud. It carved a devastating path through one of the world's largest submarine canyons, wiping out all forms of animal and plant life on its way. The disastrous flow was so powerful that it literally eroded a 250-mile stretch of the canyon, cutting hundreds of feet into its sides and damaging a total area of 1,740 square miles. That's the area of more than 3.5 New York cities. As for the force of the flow, it was so immense that it propelled massive boulders up the canyon walls to heights of up to 430 feet. Before scientists discovered the evidence of this catastrophic event, they had seriously underestimated the scale of destruction caused by submarine avalanches. By the way, these devastating catastrophes can start not only far away in the ocean, but also at estuaries. Let's go back to 14 January 2020 and see for ourselves. A turbidity current, a rapid, downhill flow of water containing a lot of sediment, rushed more than 680 miles from the Congo River estuary in the deep sea. This current appeared due to two factors: terrible flooding along the Congo River in late December 2019 and unusually large spring tides. This resulted in an avalanche of sand and mud. Its volume was equivalent to 1/3 of all the sediment produced annually by all the rivers in the world. This sediment avalanche accelerated, increasing in speed from 17 feet per second in the upper part of the Congo Canyon to 26 feet per second when it reached the end of the channel, almost 700 miles away from the coastline. This route made it the longest avalanche of sediment ever measured on our planet. 2 days later, the flow reached the deep ocean. The avalanche broke 2 seabed telecommunication cables, cutting internet data speeds all the way across West, Central, and South Africa. Now, before this disaster, scientists considered that measuring powerful deep-sea avalanches was impractical. But the sediment flow in the Congo Canyon could be monitored directly, finally allowing researchers to assess how major river floods connected to the deep sea. They also concluded that how often underwater avalanches occurred depended on where the observer was. Seafloor canyons that are close to river mouths can experience several tiny avalanches per year. Other systems far from river discharges, like the Agadir Canyon, can only have one monster of an avalanche every 10,000 years or so. You're likely wondering, what can trigger an avalanche under the surface of the ocean? Well, earthquakes, typhoons, high tides, river floods, and even volcanic eruptions. And due to our changing climate, such events become more and more frequent and intense. At the same time, these triggers don't mean that an avalanche is bound to happen, nor do they relate to the scale of the event. See for yourself. In 1755, a powerful earthquake hit the coast of Portugal, wiping out large parts of Lisbon. Tens of thousands of people lost their lives during that disaster, but it only triggered a tiny underwater avalanche. And in 1929, a large earthquake off the coast of Newfoundland, Canada, triggered the largest underwater avalanche ever recorded. The flow traveled at a speed of 42 miles per hour, carrying boulders, sand, and mud. It snapped 11 seabed cables on its journey downhill. The avalanche was so powerful, it produced a tsunami that claimed the lives of 28 people along the coastline. Now, submarine avalanches are totally invisible because they happen deep under the ocean surface, which makes them extremely hard to study. But we must find a way because these flows are super important. They transport sediments, nutrients, and even pollutants across the ocean floor. So, a research team from Liverpool decided to unravel this mystery. Over the last 40 years, they've collected more than 300 samples from the ocean floor. Combined with seismic and bathymetric data, which is a fancy word for ocean mapping, they managed to reconstruct a massive submarine avalanche. It was the first time an underwater avalanche of this size was mapped out. An even cooler thing, the event itself started off pretty modestly, but it quickly evolved into a colossal avalanche that grew to more than 650 feet tall. To put that into perspective, imagine a skyscraper-sized avalanche zooming from Liverpool to London, cutting a trench 100 feet deep and 9 miles wide. Then it spread out over an area bigger than the UK, covering it with several feet of sand and mud. That's like burying a whole country. These findings are actually a big deal because they show that even a small underwater landslide can turn into something massive and super destructive. But that's not the worst. Think about undersea internet cables, which are essential for global communication. There are more than 550 active seafloor cables around the world. Their combined length is a whopping 870,000 miles. That's enough to wrap around our planet 35 times. When a submarine avalanche breaks seafloor cables, the effects are usually super expensive and devastating. For example, in 2006, an earthquake in Taiwan triggered underwater avalanches that cut loads of seafloor cables connecting Southeast Asia with the rest of the world. The largest internet operator in China had a 90% loss of traffic to the USA at the peak of the event. As for Taiwan itself, it experienced between 74 to 100% loss in traffic to neighboring islands. So now you probably get why we need to learn more about this natural phenomenon. Luckily, researchers at Tulane University have found a way to study it in 3D. Previous studies only looked at submarine avalanches in 2D, which didn't give the full picture of how they actually behaved. The new research focused on how underwater flows interacted with mini basins, natural features on the ocean floor that look like shallow bowls. Despite being called mini, these bowls can be huge, up to 4 square miles. When turbidity currents flow into these mini basins, they don't just stop. No, they hit the far side and curl back around like water eddies in a stream. These swirling flows move the sediment around before it settles on the ocean floor. The size of the mini basin and the speed of the flow can change how the current behaves. If the basin is big and the current is slow, it starts to fill up with sediment. But if you crank up the flow speed or shrink the basin, the current starts to overflow, spilling over the basin. To study all this, the researchers created a mini version of a mini basin in a pool and used different speeds of flow to simulate turbidity currents. They even made their own sediment mixtures to see how different sizes of particles would behave. In the end, they managed to mimic real-life ocean conditions, but on a smaller, manageable scale. Pretty cool, huh?
It happened 66 million years ago. Hey, it could have been September. A massive asteroid slammed into Earth, bringing along chaos and devastation. The tragic aftermath of the terrifying collision led to the extinction of dinosaurs. Yes, I'm talking about the Chicxulub asteroid that left a massive crater in Mexico and changed life on Earth forever. And now, it turns out it wasn't the only cosmic rock to hit our planet during that time. Scientists have just confirmed there was another asteroid. This second space rock wasn't as big as Chicxulub, but it still packed a punch. It crashed to the ground off the coast of West Africa, smashing into the ocean and leaving a crater called the Nader crater. And tell you what, it wasn't a small splash. The impact was so powerful, it triggered a whole tsunami. It was more than 2,600 feet high, almost as high as the Burj Khalifa, the tallest man-made structure in the world. But how did we come to the conclusion that there was a second impact? Well, this researcher spotted the Nader crater in 2022. Dr. Nicholson was looking for some high-tech scans of the ocean floor when he noticed a massive 5.5-mile-wide depression under almost 1,000 feet of water. Well, he thought it could be an asteroid impact crater, but at the time, the evidence he had wasn't solid. But now, scientists have confirmed that this is the real deal. A second asteroid did hit Earth during the dinosaur extinction era. Now, let's see how they figured all this out. For one thing, there were those super high-resolution 3D seismic images. They allowed researchers to peel back layers of the ocean floor and get a crystal-clear look at the crater. It was like going from a blurry old ultrasound to the kind of 3D scans where you can see every little feature. Their findings confirm that the crater was left by an asteroid, somewhere between 1,500 to 1,640 feet wide. And it didn't just create a hole in the ground. The impact was so intense that it produced a central peak, formed escalating ridges around the crater, and even left a damage zone that stretched out for thousands of miles. Using those super detailed images, the scientists have managed to reconstruct what happened right after the asteroid hit the surface of our planet. First, it slammed into the ocean, creating an initial bowl-shaped crater. As the shockwave spread, the seabed was shaken so violently that it triggered landslides, and the soft sediment surrounding the crater collapsed inward, creating a noticeable brim. As you already know, the impact also triggered a tsunami, and it was so shockingly powerful that its waves didn't just go outward, they actually turned back towards the crater, leaving huge scars on the ocean floor. And this wasn't just one big wave. No, it was a whole series of them, a train of tsunamis smashing everything in their path. Now, this second asteroid impact is a huge deal for scientists. It's a rare opportunity to study a marine impact crater in such incredible detail. There are only about 20 confirmed marine craters in the world, and none of them have been captured with this level of precision before. Plus, this data allows scientists to test new ideas about how craters form in water. You see, unlike craters on land, marine craters are hidden under layers of sediment, which makes them tricky to study. But with this new 3D imaging, we can look at the crater in all its layers. It's like slicing into a cake to see what's inside. Dr. Nicholson and his team are now dreaming of drilling into the crater and recovering samples from deep below the ocean floor. This would allow them to measure the shock pressure during the impact and figure out what happened in the minutes, hours, and days following the collision. Of course, the Chicxulub asteroid is still the star of the show when it comes to the dinosaurs' extinction. This space traveler was giant, somewhere between 6 and 9 miles wide. It hit Earth at a devastating angle, sending vaporized rock and gas into the atmosphere. It caused an impact winter that lasted for 15 years, because all that stuff blocked out the sun and plunged Earth into darkness. Now, probably the most intriguing thing is that some experts think the Nader asteroid might have been a chunk that had broken off from Chicxulub before it hit Earth. It's still just a theory, but if true, it could mean that Earth got hit by a double whammy from space. Now, let's travel back in time to the year 1908 in Siberia. Look around. You see nothing but trees and rivers. And suddenly, a huge object, around 150 to 300 feet in diameter, dashes through the Earth's atmosphere. Is it a comet? An asteroid? Scientists aren't sure. What they do know for sure is that this intruder blew up in the sky over Tunguska, leading to one of the most powerful blasts in recorded history. It completely leveled the forest below, knocking out 80 million trees over an area of around 830 square miles. And that's an area larger than that of cities like Los Angeles or New York. The trees were literally flattened, and their trunks were stripped of branches. They were also arranged in a bizarre radial pattern around the epicenter. But what if this explosion had happened over a city? Every single building would have been destroyed, and countless lives would have been lost. Luckily, this disaster occurred in a super remote part of Siberia. The creepiest thing, though? When scientists finally reached the area years later, they found no impact crater. No wonder it led to even more mystery. The most logical explanation is that when the object went off in the sky, probably around 3 to 6 miles above the ground, it blew up before it could hit the ground, and still, it didn't stop the blast from leveling an entire forest. Fast forward to 2013 and another mind-blowing event, this time over a much more populated area, the city of Chelyabinsk. It was a regular February morning when an asteroid about 60 feet in diameter entered Earth's atmosphere, lighting up the sky. It was moving at a staggering speed of around 43,000 miles per hour. It blew up in midair, about 18 miles above the city. It was a horrific view, but luckily, the asteroid disintegrated high enough in the atmosphere without hitting the ground. If it had touched down, the city would have been in big trouble, because even though there was no direct impact, the explosion still created a shockwave that tore through the atmosphere, hitting the ground with enough force to shatter windows all over the place. The blast damaged around 7,200 buildings, but fortunately, there were no direct fatalities. Still, it was a major wake-up call. This wasn't just some far-off cosmic event like Tunguska. This asteroid exploded over a modern populated area, and the damage was very real. The good news? Scientists are getting better at spotting such objects before they get too close. Space agencies around the world, like NASA, are tracking near-Earth objects to figure out which ones could pose a risk. But as we can see from these two events, sometimes space rocks can still sneak up on us. And while the chances of a major impact are low, the stakes are really high. At the moment, there's one asteroid that NASA's keeping an eye on. It's called Bennu, and it's about the same size as the Nader impactor. Bennu is considered one of the most hazardous objects in near-Earth orbit. According to NASA, there's a small chance it could hit the Earth between the years 2178 and 2290, and the biggest risk date is September 24, 2182. But don't freak out just yet. The odds of the impact are only 1 in 2,700, but still, it's a reminder that Earth is always in the cosmic firing line.